Hello students, welcome to Marine Engineering Tutorials. I am Atul Kumar Gupta and back with a new tutorial. Presently we are studying marine boilers. Today we have 32nd lecture and the topic is boiler operational procedures. During the use of a boiler, various operations are carried out whose procedures are discussed in the following slides. These operations include warming up the steam pipe, blowing down, laying up the boiler, action in the event of shortage of water, detecting leakage in the boiler, and plugging the ruptured tube. Warming up the steam pipes. Before using the steam for any application, steam pipe should be gradually warmed up. Purpose. It is necessary to warm up the steam pipe before admitting steam in order to prevent their damage due to thermal distortion and water hammer. Reason for the damage. Severe damage can be caused by water hammer when steam is admitted to pipes containing water, especially when the pipe has a slight inclination from the horizontal, which may allow the water to have a large free surface area. When steam is admitted, its condensation occurs on the cool water surface or in a cold section of the pipe, resulting in a partial vacuum due to which water moves along the pipe at great speed. The impact of this water at the bend or wall can cause fracture of the pipe. Water hammer is indicated by severe and often repeated banging in the pipe. Procedure of warming up. A number of drains are provided in the steam pipe at various sections which should be left open when pipe is not in use. Drains are most essential for removal of condensate from the steam pipe during the startup. For the purpose of warming up a steam pipe, a small sized warming up valve is usually provided which acts as the bypass for steam stop valve. Use of a warming up valve prevents the damage to the valve disc and seat of steam stop valve, which can occur due to throttling of the steam and becoming wire drawn, thus eroding the metal. When the pipe has been sufficiently warmed up and the condensate has been removed from all the drains, which is evident by the release of steam, drains can be closed, steam pipe has been warmed up for the use, and the main steam stop valve can be opened now and the warming up valve is closed. Blowing down. Blowing down refers to draining the water from the boiler. Purpose. Blow down may be carried out to remove the contaminants such as oil, precipitates, or dissolved salts. Blow down is also carried out to facilitate internal inspection or repair of the boiler drum. Partial blowdown. Partial blowdown is carried out when boiler is in operation and under steam pressure. Blowing down can be monitored by noise caused by the condensation of steam. Partial blowdown should be carried out frequently, that is every day for water tube boilers for a short period of time by quickly opening the valve, thereby creating turbulence at the bottom of the water drum or header in order to remove the precipitates. It also reduces the concentration of dissolved salts in boiler water, including the concentration of treatment chemicals such as alkalinity, phosphates, hydrazine, etc. Complete blowdown. Complete blowdown is carried out after shutting down the boiler when pressure has dropped and water has cooled down, which avoids shock due to sudden cooling. It is usually carried out in a planned way unless the water in the auxiliary boiler on motor ships has become excessively contaminated with seawater. After stopping the boiler, when pressure drops to 2 bar, air vent is opened to prevent buildup of vacuum. When boiler cools down, blowdown valves are opened. Blowing down procedure. The sketch shows a boiler blowdown arrangement. Steam drum and water drum are connected with ship side blowdown valves through the pipe. Blowdown pipe is additionally equipped with intermediate valves to prevent the damage to directly attached valves due to wire drawing action of steam. Scum blowdown. Accidental entry of oil into the boiler drum is removed through scum blowdown. Liquid coagulant is added to the water which helps to coagulate the oil and prevents its spread. To remove the floating scum, a scum pan is attached to the scum valve at the normal water level. Following procedure is adopted for the blowdown. First of all, ship side valves are opened in the sequence of O1 and O2 to prevent direct application of boiler pressure on blowdown pipe. Scum valves equipped on the steam drum are then opened in the sequence of S2 and S1 to remove the floating scum. On completion of this scum blowdown, scum valves are closed in the sequence of S2 and S1. Similarly, the bottom blowdown following sequence is observed. After opening the ship side valves O1 and O2, blowdown valves equipped on the water drum are then opened in the sequence of B2 and B1. On completion of the bottom blowdown, Blowdown valves are closed in the sequence of B2 and B1. Finally, the ship side valves are closed after completion of scum or bottom blowdown in sequence of O2 and O1. This completes blowdown procedure. Laying up the boiler. When boiler is taken out of service for short or long period of time, it is termed as laying up the boiler. Purpose. Purpose of laying up the boiler is to protect it from corrosion during this period. Laying up water tube boiler for short period. When a water tube boiler is taken out of service for short interval of 2 to 3 days, boiler can be fired at intervals to keep the boiler pressure above 3.5 bar, and water must be maintained at normal level with correct treatment. This is known as banking the boilers. Laying up water tube boiler for long period. For longer layup period, water tube boiler should be topped up with de-aerated alkaline feed water along with 0.5 kg of anhydrous sodium sulfite per ton of boiler water. This will eliminate dissolved oxygen which is responsible for the corrosion. Laying up smoke tube boiler for short period. While laying smoke tube boiler for short interval, only precaution required is either to maintain required phenolphthalein alkalinity or to fill up water completely with alkaline water. Laying up smoke tube boiler for long period. For laying up smoke tube boiler for longer interval of time, water must be completely drained and boiler dried up by heaters. Trays of quicklime should be placed in suitable positions throughout the boiler, and then all the connections are sealed up by putting blanks. The line should be renewed every 2 months. Action against shortage of water. Rapid drop in water level or heavy loss of feed water indicates failure of heat transfer surface, which may be confirmed by release of steam from exhaust stack. Boilers are adequately protected against low water level by way of 2 direct reading type gauge glasses and 1 remote water level indicator for manual control. An automatic feed water control system and safety system equipped with low water level alarm and trip. In spite of all these, if water level is not visible in the gauge glass, following actions are immediately required. Securing the boiler. Boiler should be stopped at once and all the burners should be secured. Stopping the feed pump. Feed pump, if still running, should be stopped to prevent further damage to overheated tubes. Gauge glass should then be blown through to confirm the correct water level in the boiler drum. Inspection of furnace or smoke tubes. Depending on the ship's arrangement, boiler should be preferably cooled down. This may not be possible on motor ships equipped with either a composite boiler or a single oil-fired boiler working in conjunction with four circulation exhaust gas boiler. Leakage of smoke tube boiler can be easily identified by water leakage from the tube ends. It may require to raise the water level or even pressurizing the steam water site. For identification of a leaky tube in water tube boiler, entry in the furnace is necessary and it may not be easy due to large number of tubes. Isolation of leaky tube. Leaky or ruptured tube should be clearly marked, which can be isolated by plugging the tube as described in the following slide. Plugging of ruptured tube. This slide explains the method of tube attachment and its isolation. The sketch shows tube plates which may be flat or cylindrical. Tube plates of auxiliary water tube boilers on motor ships may be flat, but large capacity boilers have cylindrical tube plates. In smoke tube boilers, smoke tubes are attached to flat tube plates by welding. In water tube boilers, tubes are usually attached to the tube plates by expansion and bell mounting, although superheater tubes may be attached by welding. Both ends of the ruptured tubes are thoroughly cleaned with wire brush or emery paper to remove any deposit and ensure good sealing between tube and plug. Tube plugs are then inserted into the tube ends and hammered in lightly. Plugs may be additionally welded to the tube end. After isolating the defective tube, water is filled up in the boiler and check that plug tubes are not leaking. Boiler can then be flashed up and brought up to the working pressure. Rated evaporation capacity of boilers is much higher than actual steam requirement, such that a maximum of 20% tubes can be plugged without compromising on its capacity. Although, when 20% tubes have been plugged, all the tubes should be renewed during the next dry docking. This completes the study of operational procedures on ship's boiler. This book is written by me and covers all the topics as per Indian Maritime University syllabus. It is also recommended by Indian Maritime University as a reference book. It clarifies the concepts with simple illustrations. This book also provides answers to all the questions which have appeared in the examination conducted by Indian Maritime University. This book can help the student in preparing for the exam and also to work on the ship boiler safely. Hope you have liked the lecture. You can write your feedback in the comment box. If you have liked the tutorial, you may share it with your friends. You may subscribe to the channel for getting notification about the new tutorials. I'll be back with a new lecture shortly. Thanks for watching till the end.